Okay, I had to start over, so you're going to have to, it's going to be deja vu. We're looking at quadratics. Unit 4 is quadratics. They're very important. We're going to spend a lot of time in Unit 4. Before we dive into the math behind quadratics, we need to know the vocab that's associated with what a quadratic is, and it's a polynomial. Polynomials are an expression of two or more algebraic parts. The word part, everyone should know what I mean by that, like car parts, you know, parts of a board game. Parts of a polynomial have their own vocab word, and they're called terms. Terms are separated by plus and minus signs. Terms are separated by plus and minus signs. Everybody with me? Yes. I would hate for you to get this wrong. This is one of the easiest lessons. One of the things you can do is highlight the plus and the minus signs, and then you can clearly see there's three terms here. Just remember the signs go with the term that follows it. So like this is positive 3x squared. This is negative 5x. This is positive 2. Okay? Terms are separated by plus and minus signs. Terms is the same word as like parts, but we're talking about parts of a polynomial. Polynomial is a fancy word for many parts. Polynomial. Okay? Now, what we're going to do is look at the different types of polynomials. In order to be able to classify a polynomial as a quadratic, or linear, or cubic, or quartic, you have to have it in standard form. Standard form of a polynomial that contains one variable is written in alphabetical order with the terms in order from the highest exponent to the lowest exponent. It's from the highest to the lowest. When it's written in standard form, the coefficient of the first term is called the leading coefficient. Now, there's a lot of information here. Standard form means rearrange it so that the exponents are in descending order. I'll say it again. Standard form means rearrange it so that the exponents are in descending order. Once you have it rearranged, you can now identify your leading coefficient. Your leading coefficient is the number in front of the variable with the highest exponent. There's a lot of information there. It is the coefficient, the number in front of the variable that has the highest exponent. That's why it's called, hence, leading coefficient. It's in the front when it's in standard form. Okay? Has to be in standard form. If it's not, you can't identify it as easily. There's another vocab word in here, and that would be the word degree. I want you to draw an arrow to the exponent 4 and try your best to write the word degree there. Once you identify your leading term, this is the lead term. Once you identify your lead term, then you can identify your leading coefficient and your degree. Everything comes from that lead term. So, this is a degree 4 polynomial. My leading coefficient is 4. My leading term is 4x to the 4th power. Does that make sense? Okay, now, I'm going to cover this up with my hand. Or actually, I'll just, here we go. I'm going to cover this up. Is the polynomial still in standard form? What's left? Is it still in standard form? Is the polynomial that's left in standard form?
Yes.
Why are only 2 people answering? Should be, right? Didn't we just put it in standard form a second ago? Or we didn't put it. It was in standard form to show you that the degrees are counting down. 4, 3, 2. This is an understood 1. This is an understood x to the 0. So it's counting down. 4, 3, 2, 1, 0. You see that? That's standard form. Okay, my question to you is, let's say this one's not here. Is it still in standard form? Yes. Can you read the leading term? Very good. Can someone tell me the leading coefficient? The leading coefficient. Ty, will you get off of your Chromebook and close them? If you don't mind. I think you stepped out to go to the bathroom. But alright, so what's the leading coefficient? -2. I need everybody participating, please. -2 is the leading coefficient. What's the degree? 3. Degree is the highest exponent of the polynomial. If I said to you, can you tell me what the temperature is outside? Would you go out there and say, well, about 4 hours ago it was 40 degrees? Does that help me at all? Especially in Georgia in the fall, right? Cold in the morning, hot in the afternoon, cold again at night. So if I say, what's the temperature outside, aren't you going to say exactly what the highest temperature is at that point?
Yes.
That would tell me the degree of the weather, correct? If I say, what's the degree of the polynomial, I want the highest exponent in the polynomial. So if this is all I had, 3 would be the degree. What's the degree now? 2, or squared, right? Degree 2 squared. Guess what? This is a quadratic. This is what we're going to be working with eventually. We got to learn the parts first. But this is a quadratic because it's degree 2, which means what's the highest degree our polynomials will be as we're breaking down quadratics? Degree 2, right? May start out as more, but when I show you how to manipulate it, it's going to be degree 2. What degree is that?
Degree 3.
That's called a cubic. That's algebra 2. You'll practice with cubics in algebra 2. What's that?
4.
4, technically called a quartic. A lot of people just say degree 4. Once you get higher than 3, a lot of people just start calling it by the number. Degree 4, degree 5. That's also algebra 2. Okay? So where are we going to be? We're going to be right there. Degree 2. Okay? What's this?
Degree 1.
Degree 1, which is linear, which is old news, 8th grade math. You see it? We're building on 8th grade by introducing a higher exponent. We were going from linear to quadratic. You with me? There's a lot of math behind it. I love quadratics because it's so, I want to say simple. I don't want to discourage you if you start to not understand it and be like, she said it was simple and it's not. But if you'll practice it, it's the same steps over and over and over, so it has potential to be simple. It depends on how much time and effort you put into the play. Okay, so let's move on. You may want to write, like I did here, that this and this is understood, meaning you'll never actually label it, but it is there. Those are understood. So degree is the highest exponent. Leading term is the term in the front after you put it in standard form. Leading coefficient is the number in the very, very front, right? Okay, so let's look right here. Classifying it based on the number of terms. Okay, so this is the number of parts. If you really need to remind yourself that the word terms just means how many parts, feel free to write that word. Some polynomials have special names based on their degree and their number of terms. For example, right here, we're going to name this by the number of terms. If I only have one term, doesn't matter what it is, there's just one, right? It's called a monomial. Why do you think it's monomial? Mono means one. Have you ever been to Disney and ridden the monorail? The monorail? You know why it's called that? Why is it called that? Write the word down. What? I heard it. Yes, say it louder because the air conditioner's on. One rail. Monorail is because of the one rail. If you've ever ridden, it's kind of weird when you're Disney, the monorail. I was trying to say the phrase that they say when you're getting off of it to step away from the doors, but I can't remember how it goes now. The monorail, think of the monomial means there's only one term. Now, what type of term? Doesn't matter. It could be anything. Let me just throw some out there. 60x, love it. Somebody else give me another one. 12x, let's get creative.
X, 300.
Notice she never said an x. Is that still a monomial? Yeah.
Yes.
That's actually called a constant, and it is still a monomial because there's just one term.
5,026,000.
Can we throw in some exponents? Oh,
124.
124x to the squared.
X cubed.
X cubed, love it.
Pi squared. Yeah. 46.
I'm glad you said that. Pi squared. Good news, bad news. I love pi. If you love pi, then we're one and the same. Bad news, we won't see pi in our polynomials. So that's kind of good news because pi, when you type it in the calculator, is ugly. So this is actually not going to fall into our polynomials. What's nice about polynomials is the numbers we deal with are always from the integer family. Okay? We won't have fractions. Can everybody just take a second?
Yes.
There we go. We will not have fractions. You will not have decimals. You will have that's another one. There you go.
Hate decimals.
If you're like no, like square roots, either to the hate square roots. You will not have square roots. Yay! You will have integers. Okay. If you recall from the integer family, that would be the numbers on the number line, the pretty ones. I hate to say that. That implies the rest of the numbers are ugly, but they are. The easier to write numbers are the integer family, and those are all the type of coefficients that you're going to have in your polynomials. Okay, so coming back to this. All right. So if there's just the one term, it's a monomial. What do you think it's called if there's two? Bi. And what is something most people grow up with riding?
Bicycle.
Bicycle. Why is it called a bicycle?
Because it has 2 wheels.
Because it has 2 wheels.
That's a tricycle. 3 wheels is a tricycle.
Now, look at me. I started to write bicycle. Binomial. Thank you. Please write that down. Binomial. If my pen's writing, yours should be writing too. Yeah.
3 be trinomial.
Yes!
And number 4 be quadro.
Well, now we're just getting silly with it. But yes, if there's 3 terms, it is a trinomial. If there's 4 or more, we just call it a polynomial. That's where we're like, okay, this is getting a little too creative. let's just call it a polynomial from here on out, which is one of the reasons why I love math, because they're like, hey, this is fun. Let's call it this. All right, now it's too much. Let's just call it polynomial, okay? Now, remember what I said. It doesn't matter what the term looks like. What matters is how many there are, okay? So you'll notice that as we got higher up, there became more exponents. Well, that's because the terms have to be what's called not like, okay, let me go back. If this had 5x plus 6x right here, those were like terms, and I could actually simplify that to 11x, right? So they have to be unlike terms, meaning you cannot combine them, you're just left with what's there. But the terms, she's observing, she's making observations, she's looking to see who's paying attention. Am I doing my job? Do I have that written on the board? She's looking at it all.
But yeah,
Did you hear us being good? We did anyways when they see her coming through the door. So it's like
People switch what?
yeah, people like switch up.
Yeah, like, see how good we were just now? Like, no one's.
Well, I know, Brandon didn't go.
Yeah, and Ty and Hampton were having their kitty fight.
So yeah, it's not like accurately.
Well, I know, and that's why I wish they would come more often. I like to think I'm the same. It just puts me on edge because I never know what somebody's about to do. But let's get back to this. This stuff's not bad at all.
So,
The prefix monomial, binomial, trinomial, and then polynomial, all that has to do with is how many terms, okay? See where it says classify polynomials by number of terms? This is, by number of terms is the key part. It's how many are there, okay? So if you need to put your question here, how many are there? That's the basic question we're answering here. How many are there? Does anyone need a highlighter? Anyone else?
Did it go back from my couch for you too?
Alright. I'm setting that there so I don't forget to take it.
backwards on the couch
Okay.
all the time.
Now, next part. There's another way to talk about polynomials and name them, and that's based on the degree. So now this no longer has anything to do with how many terms there are, right? Y'all with me?
Please take a seat.
Degree, remember we said that the degree of a polynomial is the degree of the term with the highest exponent. It says, i.e. highest. What's supposed to go in the blank there? That doesn't make sense. I.e. highest exponent. That's the way we're going to do it.
Oh.
He's
Riley, just give me the phone.
So we've named it by the number of terms. Now we're going to name it by the highest exponent, which means the number of terms does not matter right here. What matters is the highest exponent.
Are you freaky?
Okay, so what do you call a polynomial that has the highest degree is 0? It's called a constant, which going over here to where y'all were throwing out examples of monomials, meaning one term, this is a constant because there's no variable with it. There's an understood variable x to the 0 power. That's why you don't see the variable. This means, go back to properties of exponents. Properties of exponents. Write the x 0 times. Well, that would mean don't write it at all. Okay? Yeah, so 300 is called a constant because it is constantly 300. The whole point, the concept behind the variable is, hey, this is 5x, but if I plug a number in for x, the value varies. Hence the reason the x is called a variable, because it's an element that changes the value. Here, if it has a degree of 0, I want you to write an x to the 0 power there so that you can understand that that's a constant. Just because she left does not mean now y'all can start chit-chatting, okay?
This is not that bad.
It's really not. Now, what if its highest degree is 1? You have already learned that. It's linear. This is from 8th grade. I'm going to make a note. This was 8th grade. You worked with linear functions in 8th grade. So right here, and you might say, well, I don't see the 1. There's an understood 1 here. You don't ever write it, but it is understood. Okay? So if you don't see the variable, it's understood 0, which makes sense. Write the variable 0 times, which means it's gone. If you see the variable but no exponent, it's an understood 1. All of the other exponents you're going to see. If it's a 2, you're going to see a 2. If it's a 3, you'll see the 3. If it's a 2, it's called a quadratic. I need you to know that word, like forwards and backwards. This is unit 4 for us right now. Quadratics. This is unit 4. Now everything else is algebra 2. That's your junior year of high school. So if it's degree 3, it's called a cubic. If it's degree 4, technically it's called a quartic. Some people just say degree 4. But you could call it a quartic. Notice there's nothing else after it. That's because we just say degree 5, degree 6, degree 7. Notice over here, all this other extra stuff was in the examples. But we don't care. This stuff does not matter at all when you're naming it based on the degree. The only thing that matters when you're naming it by the degree is your leading term. None of this matters. You with me?
Yes.
This could have had a ton of stuff after it, x to the 4th, so I could have had 3x cubed minus 2x squared plus x minus 4. All of this could have been here. Doesn't matter. What's the degree of the polynomial? 4.
4.
Okay.
It's 4.
All right. Let's practice rearranging it in standard form and then naming it by degree and number of terms. When you rearrange it to standard form, I need you to think of a cup game. Do y'all remember the 3 cups? You put the ball under one of them and then they're just shuffling them?
Yes.
Okay, I need you to think of that concept here. I would draw a slash between the terms so then you know what sign goes with which term. So right here, I've got 15 minus 4x squared plus 2x to the 5th. I'm going to put a slash after the 15, after the squared, and then that's it. Now I can see clearly how many terms are there. 3. There's 3. So it says number of terms. There's 3. Then I would go to the front and I would remind myself, if it's 3 terms, it's called a trinomial.
I knew that. I wrote that down.
Now, we need to rearrange it into standard form. The highest term, the leading term with the highest degree needs to come to the front. Which term would that be?
2x to the 5th.
2x to the 5th. Notice it's positive, so I'm going to cup game that, shuffle it to the front. So 2x to the 5th. What would be next?
Negative 4x to the 6th.
Negative 4x squared. And then what?
Plus 15.
Plus 15. Now it's in standard form.
Wow.
Easy peasy.
Do you notice something missing?
Wait.
Which one?
Look at that.
The x to the first power is missing. That's okay. That happens sometimes, okay? They don't have to all be there. But also to the fourth power and the third power is missing. That's okay. Now it says, what's the degree? Well, I would like y'all to circle or box. It's up to you. Or highlight. It's up to you. I would like you to box in or circle your leading term. No, that might get crowded. Let's don't do that. How about this? We'll put it right here. What did I just do? Let's copy your leading term. Woo, where will we put it? Let's see. We'll copy it right here. Leading term right there. So what's the degree?
5.
5. Now you need to name it by degree 5. Well, like we said on the front of our paper, anything higher than degree 4, we just call it by the number. So this would be degree 5. Ah. So degree 5 trinomial is the correct way to name it. Degree 5 trinomial. All right, you do number 2.
I got this one.
All right, so for number 2, if we put slashes to separate our terms, does yours look like that?
See? Yes.
Make sure you're putting the slash right after the previous term, okay? So that the sign that goes with the next term is not getting cut off. So like I see 20x, I see negative 4x cubed, I see positive 1, and I see negative x squared. So really quickly I can see how many terms are there? 4. And if you recall, we said that when it's 4 or more, we just say polynomial. Degree is where you are looking at your leading term, and you can't really decide that until you have it in standard form. So what needs to be in the front?
Negative 4x.
Very good. Second?
Negative x squared.
Negative x squared. Next?
20x.
Plus 20x. Next?
Plus 1.
The x did not come out right. Here we go. 20x plus 1. Now I can see that my leading term, I guess I'll call it LT. This is bothering me not labeling it. LT is negative 4x cubed. So what's the degree?
3.
3, which means we can actually call this a cubic. This is a cubic polynomial. For some reason, cube, which makes me think 4, is actually 3 in polynomials. I'm recording, y'all. Alright, standard form number 3. At this point, you should already be working through them.
I am right now.
Yeah, I'm actually. You should not be waiting on me. So 3, we can see the terms separated. Now notice this has a y instead of an x. That's okay. That happens. How many terms are there?
3.
3. So it's a trinomial. To get it in standard form, you should have pulled y to the 4th to the front, then y cubed, then minus 3y. So what's the leading term?
3.
Y to the 4th, which means it's degree 4, which technically is a quartic.
Oh, I put down first.
Think of, there's 4 quarters in football, right? There's 4 quarters in $1.
Well, I had it.
Degree 4 quartic.
Monday.
Quadratic is, quadrant, no.
This is not cut.
All right, number 4, I can see that there's only 2 terms, so this is a binomial. To get it in standard form, I just need to shuffle the 3x to the front. What's the degree?
1.
This is degree 1, which makes it,
Constant.
careful, if I can see the x, it's linear. Degree 1 is linear. Can you quit, please? Degree 1 is linear. Constant would be just a number by itself, period. No variable, nothing. All right, this last one, is it in standard form? Yeah, don't overthink it, y'all. There's nothing to shuffle. So the leading term is exactly what you see there. It's degree 2, so it's a quadratic, which is what we're studying. There's only 1 term, so it's a monomial. Notice the difference in number 1 and number 5. Both are monomial. I'm sorry, I said that wrong. I was thinking on the other side. Oh, scratch that, what I was about to say. I was about to compare it to something else and it didn't work out. All right. Something that I need you fresh on. This is really important. If you cannot successfully do 6 through 11, even as ugly as it gets right here.
Oh, I can do this.
Now you may see, okay, I see there is a fraction here.
Yo, you said there's no fractions.
Not in polynomials. This is just can you multiply. This is just can you multiply. There's no polynomial with an actual fraction in it, but this is just can you multiply. Which, by the way, that's just a half, and every single one of these is even. So it's not going to be a problem. All right. We are going to multiply a monomial into a polynomial. This is your monomial. This is your polynomial. It is using the distributive property. It's just like when I am distributing papers to start a lesson. Everybody gets a paper. Can y'all please stop talking? So every single term is going to be multiplied by the 2x squared. Every term. Remember your product rule with your exponents. If you have x to the m times x to the n, you simply add the exponents. Okay? So here we go. Ready? 2x squared times 4x to the 4th. Multiply your leading multiply the coefficients.
8.
2 times 4 is 8. Copy the x, girls. And then x squared times x to the 4th, we are going to add the exponents. What would it be?
6.
X to the 6th. Repeat. 2x squared times negative 3x cubed.
Negative 6x.
Negative 6x to the what?
5.
To the 5th. Repeat. 2x squared
4x.
times 2x. 4x. Keep What would it be?
X2.
Just add the exponents. Add them. 3. There's a 1 here, right?
Oh, shooting too.
Oh my gosh.
2x squared times negative 1. Yes, you can. You can multiply anything. You can only add it. Negative 2x to the...
Third.
No, there's no...
Oh, so now it's the second. Okay.
Yeah, there's no x there, right?
Stuart, who do you think you are?
What did the one?
I multiplied it. Anything times 1 is this, so... I know that.
Yo, was that a tie?